So welcome, I'm Yannick Christiaans, and I would like to welcome you to this first 2021 webinar of Craft. On behalf of all the partners, TU Clausthal, Aalto University, HIT Innovazione di Trentino, Vito Arkema, Craft will be introduced to you all. We will also do a short summary of what we did, very briefly of what we did in 2020 before mentioning what's planned for 2021. And then, of course, the reason why you all joined this webinar, our inspiring keynote from Sebastian on his company, Yuma Labs. So first of all, briefly introduce to you what is Craft. So Craft is an international consortium of European universities, knowledge institutions, and industry. So we are University of Ghent, Aalto University, Technical University of Clausthal, Vito, Hub Innovazione di Trentino, and Arkema. So we combine the best of academics, other knowledge partners, and industry. What do we do? This project is very ambitious, so I try to visualize it a little bit in a word cloud. And our main slogan is actually that we try to foster circular design using additive manufacturing. As we consider this being one of the key technologies and helping establish a more circular economy. And we try to do this by bringing PhD students and professionals together to work on new innovations in a hackathon format. This is a 2-year project made possible with the support of the EAT Raw Materials Academy, which is a European institution for innovation and research. So last year, which was the first year of our project, we had our first hackathon, Circular Sprint. Due to the COVID pandemic, unfortunately, we could not host a hackathon, a physical in-person hackathon in Kortrijk, Belgium, as we planned. So we had to organize an online format, a very intense format, as you can see here on this slide, a format which took part on Zoom, where we hosted the online lectures. Teams collaborated using Miro boards. There were 9 coaches present, and we were working on 5 different cases with various partners. Since we believe in this project, it's very important to work on real industry, on real life cases, so no theoretical cases, and then also making the outcomes tangible. So everybody who participates in Circular Sprint is also challenged to prototype their solutions. Last year, we worked together with Honda, Amble, the city of Roeselare RD Physics, and Stoneflower 3D printing. At the end of the project, all participants, all teams were asked to present their results. We 3D printed using recycled materials on entry-level printers, but also on our clay printer, and there are very interesting results coming out, some of which are leading to follow-up projects. So in 2021, we will also be organizing a new circular sprint, and I will give the word to Thomas, who will tell a little bit more about that.
Yes, thank you, Yannick. Okay, do you now see the presentation again? All right.
Yes.
So good afternoon also from my behalf. I'm Tuomas Puttonen from Aalto University, and I will give you a small peek into the year 2021 and the Circular Sprint event. In fact, which will be 2 events we will be hosting this year. So we are ramping up from the first year. We have an event happening in TU Clausthal, hosted by TU Clausthal, the Clausthal University of Technology in Germany, and then by Aalto University here in Espoo, Finland, by the Advanced Manufacturing and Materials research group, the research group destined to study 3D printing that we will be hosting the event. And the initial target dates for this year's event will be mid-September, weeks 36 and 37. And if we look a little bit into the format and the schedule of Circular Sprint 2021, based on the feedback of the first year's edition, we are a little bit splitting the content to 2 weeks to make it more digestible and accessible also to participants. So the first week would be pre-teaching online and arranged thematically, the basics or introduction to circular economy. On Wednesday, then design strategies and business models for circular economy. And on Friday, focusing on 3D printing and circular economy, so design materials. And the second week is focused on the sprint, following steps of a design sprint, and actually getting hands dirty and advancing the challenges or solving the problems given by the companies as a team. And we would have the agenda, the schedule culminate in a weekend hackathon. So this year, depending on the pandemic situation, we are of course hoping that we could be organizing the weekend hackathon as a physical event. So prototyping with the teams in AdLab, Espoo, Finland, and also in Germany. So that's in a nutshell what 2021 events will be about. And stay tuned for more. And you can visit our website, craft.eu, to subscribe for news. Also, you can follow the Craft pages on LinkedIn and the EIT Raw Materials Academy on Twitter. And for companies who would be interested to join the event with their own challenge, you can contact us, of course, directly, or then also via the contact form on the webpage. But to keep it short and cut to the chase of today, we will be having the Yuma Labs keynote by Sebastian. And Yuma Labs is a laboratory that produces high quality eyewear from recycled materials under their own label and for other fashion brands as well. And if during the keynote you would have some questions, you are free to post them in the chat. We will have a Q&A session at the end and also time for free discussion. And at that point as well, if you have any questions related to the Circular Sprint event of this year, you can also post and ask those questions. But now I will give the floor to Sebastian. You're welcome.
Hello, everybody. Thank you for this opportunity to share our story of Yuma Labs, how we make circular sunglasses and how we use 3D printing with that. The 2 topics in your program, circular economy and 3D printing, are 2 topics that really passionate me and that we work on a daily basis. I'll now share my screen. I've got some slides prepared. There you go. You can share my screen. Yeah, that's correct. This is a screenshot of our homepage, totally circular. Obviously, we're talking about sunglasses, tomorrow's sunglasses from yesterday's waste. We're taking these words very seriously. We want to make future-proof sunglasses that not only last one summer or two or three, but in effect, endless summers. And that's what we really aim for with the circular economy, to build a product in such a way that it is not only circular, but also more convenient and better quality than the sunglasses that you would normally find in retail. In the next few slides, if I can go to the next slide, that's it. I'll give a short overview of what we mean with circular sunglasses, how we take that into effect, a bit of the trajectory of our startup from 2016 till today, where have we been, what kind of mistakes we've made, where we wanted to go, where we're not going, and where we're going today. I'll walk you through with a few slides and quite a few videos on the process that we use for 3D printing sunglasses from recycled materials. Obviously, I'll share some projects that we've done with other organizations and partners, again, around sunglasses, and I'll finish off with new technology, new 3D printing technology, which we are prototyping at this moment. A bit about myself. I'm a mechanical engineer by education. I studied in Delft, and just after my studies, I started working as a circular economy consultant for startups. I did that for a bit over 5 years, but at some point I got tired of talking about it and leaving very good and sexy ideas on Post-its, and I really wanted to make my hands dirty and start entrepreneuring and putting into practice myself all these concepts that I've been working with. And circular economy and 3D printing were very much at the center of that. Before I dive into sunglasses, first an explanation of why sunglasses. What we want to do is make circular economy as sexy and as tangible for people as possible, rather than having sustainability and circular economy as something that people ought to do. We want to make it in such a way that people want to actually become more sustainable and circular. Obviously, not only with sunglasses, but we think if people can do, and if we can build a product that is entirely circular with sunglasses, we can do the same thing for this computer mouse and for the computer on which we are all watching today. With Yuma Labs, I'm sure you've seen these graphics before in your program. Difference between a linear economy and the recycled economy and a circular economy, we take very literally. So that means that we not only use recycled materials as much, recycled or biomaterials as much as possible to produce, to make these sunglasses, but we also, and that is even more important, want to make sure that at the end of life, those same materials can go back to us for disassembly, recycling, and remaking them into sunglasses. So we really want to avoid any downcycling whatsoever and make this in a completely closed cycle. How we do that, specifically on disassembly and take back, what we've developed and what you see here in a short GIF which is playing is what we call the sandbag case. Everybody obviously knows you've got a pair of sunglasses that comes often with a case that you use to protect it. This is this everyday case that you use day in, day out. At the end of life, when the sunglasses are ready for recycling, there is an integrated free shipping label which easily peels off. You fold out, and with that you seal this sunglasses box. At that moment, it becomes technically an envelope. So from everywhere in the world, you can just drop it in any street post box, and it will take a bit of time, but it will end up again in our doorstep here in Antwerp. Then we work together with social workplaces, locally employed, to disassemble, separate, clean and recycle the materials as much as possible. There's a bottle of PET at the bottom of the screen. That is what we currently and mostly use for the sunglasses. We did not start off with just PET. but I'll zoom more into that later. As said, sunglass, and that's one of the reasons why we started with 3D printing, is one, being a startup. Obviously, with 3D printing, you have very small startup costs. To produce one model is very cheap when compared to, say, injection molding or CNC technology, but it also allows to conceive a product in such a way that it can be quite easily taken apart with very little or very easy manipulable tools. So that is very central in what we do. A bit of background, how we started. 2016, when I was alone with this company, as often startups either grow in their garage. In my case, it was in a kitchen table. I bought my first Ultimaker 2. I didn't even have a VAT number at that moment, so I just bought it for my own savings. I didn't know anything about 3D printing or 3D design, but via lots of YouTube videos and via lots of back and forth with people who I've gotten to know could help me further. It took quite a while, as you can see, until the end of 2017 before the product was actually ready for putting it out into the real world. We did that via a Kickstarter crowdfunding campaign, which was then launched on the name, by the way, Yuma. We are Yuma. That's before our name change. The reason for these name changes is primarily because Puma, the German sportswear multinational, did not allow us to use the name Yuma, so we had to find different ways around it. And We Are Yuma was the previous one. Now Yuma Labs claims a whole lot better than what we do. Beginning of 2018, we shipped this first batch of the successful Kickstarter, but with the haste to which we went to market, quite some issues turned up with the sunglasses. They were not as sturdy. The materials were not as stable as they seemed to be in the development phase. So in mid-2018, we did a whole redesign, not only of the product, but also of the process. How the kind of materials, the kind of hinges, for example, that are being used, and the production process that goes with that. Second collection was then launched beginning of 2019. And indeed, as Thomas said in the beginning, we produce under our own label, Yuma Labs, but we also produce for fashion labels. That's a way to even increase the impact, because we can only reach as many people as buy our sunglasses or read about us or follow us on social media. But if we can work together with partners in the fashion industry, we can not only reach more people, but we can also reach people who would normally not be entirely engaged with sustainability or circular economy, who are open to it. And that is really what we want to do. We want to make more people enthusiastic on this. 2020, obviously, beginning of the year, was COVID, which for us, as for a lot of companies, caused quite some headaches in terms of supply chain and in terms of markets. Then, towards the end of summer 2020, we launched a new crowdfunding campaign, this time not with 3D printed sunglasses, but with injection molded sunglasses. At that point, we changed the name to Yuma Labs as well. We will soon be shipping this new crowdfunding campaign, and in the beginning, during spring 2021, which is this year, we'll be launching a new collection of 3D printed sunglasses with a different production method. Now, I'll take you back a bit in history. These are photos from a video that I'll be showing just after, but I quickly wanted to walk you through the steps of how the general process looks like. These are not the actual photos. Like, the first photo is a shredder where the PET bottles are shredded into tiny pieces. This is just a hand-operated machine that we have here in our microfactory, but obviously this is done in an industrial scale by our partners. So PET bottles being shredded. Hold on one second. Before going into PET bottles, on the top row, you see different kinds of materials that we use. Initially, we started off with ABS as well, 100% recycled ABS that was from old car dashboards. The white sunglasses in the middle are from HIPS, from recycled fridges from the Netherlands. And the third one, either in translucent or in black, are the PET bottles. That's the one that we stick with in the end, because ABS and HRPS are wonderful to print with, but they don't make the best sunglasses. All right, so after the shredding of the soda bottles, filament is created. This is the top right photo. Then we don't have anymore, we had our own 3D printing farm of 9 printers. The dashboard that you see here is from the Belgian-built tripod maker. It's a wonderful printer, which actually can have quite a big print velocity and volume. After the print, as you all know, you get a very layered structure, specifically with FDM, but if you use the position modeling, you've got a very characteristic feel to these elements. Then you've got a polishing step, and afterwards you've got a more classical assembly of the hinges and the lenses that go with it. I'll quickly show you the video, which is just a bit more than a minute, which illustrates the production process. I hope you've got audio as well. See, that's one of the things you can do when you do everything in-house. You control all the steps of the production process, but it also means that every step of the production process is a place where you've got a variety, a variance in the production process. As I spoke in the beginning, one of the things that you have with, obviously, a pair of sunglasses is that you have a curved surface as well for the front as for the temples, because it needs to fit a face properly. And as most of you will know, 3D printing with FDM is on a flat bed, and they're moving upwards. We've tried lots of ways to work with support, breakdown support in one way or another that could still leave a beautiful result. But as the sunglasses are being printed face down, the part that is most obvious, which you wear actually outside, is the part which actually is on the bed. So any support at that level was not possible. One of the things we tried, which worked on an experimental level, but did not work on a production level because it was not very reliant, is using a curved bed. You can see here, there's an Automaker 2, where a glass plate was put into an oven and got exactly the curvature that we needed for the front, as well as the heated plate that went with it. This is just a give that shows, after lots of calibration, lots of tweaking before actually getting this leveled out in the exact way that was needed to create a nice result. So there was, in fact, rebuilding this whole Ultimaker 2, taking it apart, and then putting it back the way it was before. So it is possible. It is possible to do this, but it's not very viable if you want to do it on production process, which is and still is one of the drawbacks from FDM 3D printing. FDM printing using 3D printing filament is that the variation in the print quality is an issue, and you don't want that if you do long-term production. One of the other projects that we worked with was together with a children project where we took plastic, again, PET bottles from the River de Scheldt, which runs here through the city of Antwerp, and then we turned these into children's sunglasses through an educational project where they could put them together. This is a slightly longer video of a bit more than 2 minutes, which explains it all. It's in Dutch, but there are English subtitles. right? I mentioned in the video as well that, can I go to the next one, is that 50% of the sunglasses are from river waste. This is pure PET, which was then mixed with PETG to create a more stable filament, which would print better. Obviously, at that point, you're mixing materials, which is actually, of course, you know, in a circular economy is a no-no. But for this project, as the volumes were very small, our supplier agreed to take back the mixture of PET and PETG because the volume was that small that it would not disrupt their sorting system. But these kind of hacks need to be used to make a usable process. Now, are our sunglasses 100% circular? No, they're not. There's still some challenges. For example, the recyclability of the lenses, and the lenses are quite a big chunk of what the sunglasses are. There are lots of different materials which can be used in the lenses. You've got thermo-harder plastics and thermoplastics or glass, but none of them can be recycled. So there are no glass lenses made from recycled materials. There is for some a possibility, say polycarbonate lenses, to recycle them at end of life, not to make glasses again or lenses again, because you will not get a sufficient quality of the glasses itself. And the moment a polarizing filter is being added as well, the recyclability goes out of the window entirely, because that will disrupt the recycling process all the way. Another challenge that we know we will have to encounter, but we have not encountered yet, is disassembly at scale. We have done disassembly here in our own microfactory, but if volumes go up, we need to find a feasible and an economically viable model through which we can handle larger volumes of sunglasses to be disassembled in an efficient and cost-effective way. As mentioned before, for this, we're looking to work together with social workplaces here in Antwerp in such a way we can use locally employed labor while providing new opportunities for people. Then a third challenge on which we have done some steps, but we're not quite there yet, is removal of the paint. As with 3D printing, if we're printing black frames, then the material that goes in there is actually black pigmented. So there is no way that this material can go back in a general waste stream because it is pigment that carries it with it. If the glasses are being printed and then spray painted, are being colored, then you need to find a way to remove either this dye, if we're speaking about SLS printing, or the paint for 3D print and injection molding. There's several ways to do that, several viable ways that will surely remove the paint. The chemical ways of doing that with quite nasty chemicals. There are mechanical ways of doing that, but we still need to find a feasible way to do this in an economic sense as well, because doing this in a short, limited volume is one thing, but again, doing this at scale is quite another. Then another project which I'd like to share with you is a project that we've done together with a Belgian festival, where we did a very similar thing as we did with the kids at Stormcop. Again, 50% of recycled plastic and 50% virgin plastic, where we collected cups at a festival to make it into a limited edition sunglasses. This is the next video, which I will show you now because it explains it way better than I can. That's which I think is a wonderful example of what you can do on a very short time scale and a very short limited edition, because this was done only summer last year. Because of the COVID, obviously there was no physical festival, so there was an online festival, which gave us an opportunity to directly use the waste of 2019, the festival the year before, and we sped through a whole process of treating, cleaning, shredding, creating filament from these materials in such a way that it could still tell the story of 50% recycled content, while still having a product which was feasible in terms of 3D printing, which gave reliable results, and was actually strong enough as well. Because PET, when compared to PETG, tends, if it does not cool under the right conditions, tends to be a bit more brittle than PETG. So that's a reason why most of the PET materials on the market for 3D printing have glycol added to it. Now, if you're looking forward to new materials and technology, as I said in the beginning, we started off with 3D printing, with everything in-house, from design to product development, to production, to packaging, to marketing, to sales, to after sales, and everything that goes with it. We made a choice a bit more than a year and a half ago to focus on these aspects that we know we can do best, and outsource those with partners who are specialized in a specific field. So that's why one reason we have started working with injection molded frames, which is exactly the same concept. You've got 100% recycled PET. PET is a wonderful, strong, flexible material which lends itself very well for sunglasses. But with injection molding, obviously you've got a way higher startup cost, because the mold costs tremendously expensive. So you're bound to higher volumes. And again, with injection molding, you've got a paint add-on on top of the model once injection molded, which gives another challenge for recycling it at end of life. The hinges, by the way, I didn't talk about that. That's metal, obviously, so that is easily recyclable. If it were not that the screw, the tiny screw that goes into an eyewear hinge, is often from stainless steel, whereas the hinge itself is from nickel silver. So these needs to be separated, even though how tiny these elements are. These need to be separated at recycling as well. So the new materials and technology that we're looking into, and we have done several tests, is not via FDM, via fused deposition 3D printing like you saw in the first video, but this time via selective laser sintering and multi-jet fusion. This is an entirely different 3D printing technology. Maybe you've looked already in depth at this, I believe so. As you know, these are powder-based nylons, often, which are used for making sunglasses. When I started off with the project, I don't think there was, or at least I was not aware of any materials that could be circular in this technology. The most used nylon is PA12, often the cheapest as well to print with. PA12, as all the research that we have done, is recyclable post-consumer, but it stays very expensive. And having it recycled back into either powder for SLS 3D printing or for injection molding, again, is feasible on a laboratory scale of what we've understood, but not yet on a commercial level. The reuse of power is, though, something that is being used. I know it's being done by Materialize, but also by others, where you've got a higher content of non-used. Powder is actually better wording to use in the making of sunglasses. Obviously, this is not post-consumer waste, but pre-consumer or post-industrial waste. A better candidate, the one that we are looking into now, is PA11, supplied by Arkema. which is not made from recycled materials, but it is made from biomaterials. In this case, from castor seeds, which is a plant which for 75% of world supply comes from India. And if grown under the right conditions and under the right social embedding and help that goes towards local farmers, I believe this really can be a viable alternative. It does not it's not in contrast with food crops for this matter. So it's actually a third generation biomaterial, and it is recyclable as well. Not chemically yet. It is not recyclable to make it back into 3D printing powder that can be used back in SLS printing, but it is under the right conditions mechanically recyclable for injection molding. And as told before, that is also a material that we're using. We have not closed that loop yet, so we have not recycled PA11 and tested with injection molding these parts still. One of the issues that I expect we'll run into, that if PA11 is recycled, it becomes an injection molded, the flexibility becomes an issue. It becomes too flexible, which might not be so good for quality sunglasses, but for children frames, which we're making as well, it might be a viable alternative. Then the one on which I really have the highest hopes, but not for the short future, is PA6, obviously also a nylon, which is chemically recyclable. And in this case, it is technically infinitely recyclable without losing the mechanical properties. But as the test that we have done, it's very early stage material. The prints that can be made with PA6, which is quite a cheap material, are, to our experience, too brittle to make them into sunglasses. Is that due to the nature of PA6 itself? Is that due to the nature of the powders that are being produced from these PA6? That is still unknown. As with all these nylons, they can be elements added to it. They can be glass filled, for example, which in some cases might strengthen the material. In the case of PA6, it makes it even more brittle. So that is something that we're absolutely keeping an eye on. We don't have the budgets internally to put a new research project out on this, but if this will be possible, we will be sure to be one of the first to employ these into sunglasses. I'm almost at the end of the presentation. This is more of a reach out to you, to the further community on knowledge sharing on FDM, 3D printing, laser sintering, or multi-jet fusion for circular applications. Like I said in the beginning, circular economy, 3D printing, on these two topics are what we work with on a daily basis here at Yuma Labs. And as I just spoke before, the recycling option with these 3D printing powders, being it either PA12 or PA11, I believe there's still a lot of unknowns which have, as far as I can see, not have been as thoroughly researched as might be needed. And that is something that Yuma Labs really stand for. That is what the labs in Yuma Labs represents, is that we are very much a laboratory of change. We want to experiment, and we've got a platform to do that as well. With our early customers, we have a base for testing products under our own name, which are experimental in nature, being that on the production method or the materials used. So you've got a testing ground with which materials can go out of a laboratory setting and be tested into the real world. Waste is over if you want it. We want it, obviously. You're based in this program, so you agree, I think, on this message. So if you got any further questions, please unmute, raise your hand, and I'll zap through the PowerPoint or answer your questions as best as I can.
Okay, thanks. We do actually have some questions already in the chat.
All right, didn't see it.
So, and also if people have more, just you can unmute yourself and keep them coming.
I cannot see the chat if I stop sharing, I think. Oh, no, there you go. Where's
Okay.
the chat, 14.
I can also.
Yeah, no, I see it. I see it.
Okay, good.
Shall I run through these questions? Is that?
Yeah, I think there's 3 questions pending. So maybe if we go through these and then we can carry on. With,
yeah. That's good. Sounds like I guess it's fine. Questions. I'm just stepping through to one of them. What are other products besides songs that could be easily developed in a similar method? That's a question from Olaf van der Meer. That's for the first of 3 questions. We did a lot of thoughts on that, like what else other than sunglasses could we make in a similar fashion? 3D printing, maybe not with SLS, but certainly with FDM, you've got a limited build volume, obviously. So you're quite restrained to the volume with that. We had some opportunities to work with other products, but we wanted to make sure that the products that we put out into the world are actually usable products, are actually products that people need in a very real sense. Sunglasses obviously have a fashion level icon to it, but they really do protect your eyes. One other thing we could make, say, are vases for putting flowers in, which at some level is a very useful and needed product, but we really want to make sure that we steer away and clear off from gadgeteering and making something because we can make it. We want to make it as useful as possible. I hope this answers your question, Olaf. Then I'll jump to Stephanie. Stephanie asks, how do you think injection molding and 3D printing compare in terms of circularity? That's a good question. Looking at FDM and injection molding purely on a material level, I don't think there is that much difference in terms of circularity, in terms of recyclability, that is, I'm talking. If you're taking sustainability at a larger level in terms of energy input needed to produce one 3D printed frame versus an injection molded frame, I don't know the answer either. I believe to make a pair of sunglasses using 3D printed, that lasts a very long time. The time needed to make a pair of sunglasses entirely in a 3D print is a bit more than an hour altogether. So that's a lot of energy that you put very concentrated on one point. With injection molding, this obviously goes a whole lot faster, but you first need to produce the molds. And you've got other larger machines which need to be heated. If I think of another thing that I can add to this question, I'll come back to it later. Yannick, you've asked a question. Your question was, when sales really take off and considering the product lifespan, I presume you need to get extra waste streams to produce the glasses. Yeah, that's one of the questions we often get, indeed. By using waste streams, don't you make yourself dependable on a problem which you want to get rid of in the first place, right? If we use recycled materials and we stick to that, then we got an inherent incentive to make sure there is still waste. But if we can close the loop 100%, technically, then at some point we would not use any new materials because all the materials that we need to produce new sunglasses would come back via recycling. But that's just a hypothetical case, though, because that would mean that you've got a stable growth, you don't get growth in sales, and you can close the loop entirely that everybody sends their sunglasses back. Will that ever happen? I don't think so. But I think with bioplastics, as for example with the castor oil, you can go a long way moving away from petrochemical plastics, which I think is absolutely a direction we should be going up. Kim Niklas asked a question. Next question. What is the reason for discarding old sunglasses? At what point do people send back the sunglasses to you? Broken, scratched, lens, fashion? That's a very good question. First of all, we give an incentive to people to not send their sunglasses back a month after they've bought it. So the longer people hold on to their sunglasses, the higher the discount they will get on the purchase of a new pair. In this way, we give an incentive to people to wait as long as possible and to use their sunglasses as long as possible, because the most sustainable pair of sunglasses are those that you wear the longest before anything. But the decision on which point the sunglasses are being considered ready for recycling lies with the end consumer. Is that a perfect system? Maybe not. Are part of these sunglasses not ready for recycling, but maybe for resale as well? Surely, possibly. But we have not found a way yet to integrate this into a business model. Okay, then Enrico asked the next question. Can you tell us a bit more about your first steps as a startup? What helped you the most to transform your idea into profit? Well, I made a lot of mistakes, I think, which a lot of people, young people who start their own company do. One of the things which I did not do well in the beginning is try to do everything myself. So in terms of product design, in terms of product development, production, shipping, logistics, sales, everything that goes with it. You cannot be good in all these points, and you get actually overloaded with work. Another thing, what really helped as a first step in a startup is joining a startup program. The first program I joined was in Liège, in Luik, in the French-speaking part of the country, and after that here in Antwerp at KPC started. And what this does is you get an environment, an incubator environment, where not only you are in direct contact with other startups, more often than not, these startups do not produce a product, they produce a service, but nonetheless, you get very viable support and feedback from them. That's one. And you get access to coaches who can help you on a financial, business model, technical, or marketing perspective. Yeah, so getting others people input, but not too much either. That's another mistake we made at some point, is getting too much help, too much advice, and then you become paralyzed by analysis, by having too many opinions or too many views. Good. Then Yannick asked another last question in the chat so far. Thank you for the answer. Could you share a ballpark figure about the number of sunglasses which have been sent back? That's a good question. I don't know exactly. It's a box. It's a small IKEA box full of sunglasses at this moment. In terms of kilograms, in terms of number, I don't exactly know. We can check, obviously, in our stats, because we work together with bpost for this. We've got a special program with them through which we can generate the labels as indicated on the in the sendback case. But the volume is relatively high, and that also answers again a bit the question from Kim Niklas. If you remember the time frame which I presented in the beginning, the first generation of products, we had quite some problems because the temples broke, they were not solid enough. So quite some people did actually quite soon came back with the sunglasses. So the volume of sunglasses coming back was the biggest thing in the beginning, sadly enough. Good. Anyone else have a question in chat or wants to unmute and ask a question? Feel free.
And maybe also about the postage. I was just thinking that as the customers send back the glasses, is there a catch? Well, I guess obviously probably you will pay the postage for them, so it's included in the price. But will they also get the discount for a new pair of glasses, or how does it work?
Yeah, that's correct. Indeed, it's a ladder. When people, like, if people send back the sunglasses within 1 year of purchase, they do not get a discount on the next pair. But if they send back in the first year, they get 10%. Second year, 15%, and from then on, it's a flat rate. So people get a discount indeed on the next pair of sunglasses they can buy with us. There are various ways of doing that. if, as mentioned, we produce under our own label, but also for other fashion brands. And with them, and that is what we're really aiming towards with the sunglasses, if we can find a way that the customer at end of life not only returns his or her sunglasses, either via mail or in person in store, but they also walk back to the company. In this way, you don't have the only circular materials, but you also have circular customers. And acquiring new customers who buy from you from the first time is expensive, either online or offline. So if you can build a long-term relationship with your end consumer, then that's of high value. And even more so for children's sunglasses. I made these children's sunglasses as well. Children, obviously, they grow out of their sunglasses. So every so many years, they would need a new model. All sunglasses then ready for recycling? Probably not. But if we go towards such a system, then you are at some point providing more of a service than a product. And I think that's, in the end, still the holy grail of circular economy. If you can towards not necessarily owning your sunglasses, but leasing or renting them at some point. I see another. I see another question from Louisa. Can you ask the recycling facilities to get your own sunglasses material back? Or do you recycle them yourself on a bigger scale as you did with the children gathering the materials? Can you, hold on, I'm not sure I understand the question. Recyclers to get your own sunglass material. If I understand the question correctly, Louise is asking, if I send back my sunglasses, could I have a new pair of sunglasses from this exact material? The answer is no. It would be amazing if we could do that, because then at some point you could initially sell not so much a pair of sunglasses, but just a few grams of plastic that would travel with you, gain different shapes, different style, different models as you go along as a customer of a company. But having separated these on a one-by-one level is not feasible, certainly not economically feasible. But it would be amazing if that could be done. If there is one technology that would allow that to do that, is via 3D printing, that's for sure. Okay, I go to the next question from Stephanie. Will the metal hinges actually go to be recycled, or are you able to pull them out at the disassembly stage and reuse? It's a good question. I didn't touch on that yet. One advantage of 3D printing, as much with FDM or SLS or multi-jet fusion printing, is that these kind of hinges tend to be not molten into the structure, but screwed into the sunglasses. So they actually can be removed by unscrewing two tiny screws, which will make that you have the clean hinge as you inserted it before. That's an advantage that you have with 3D printed glasses, that you can literally unscrew them and disassemble them. With injection molded sunglasses, that is not possible, but you can heat them to such a point to which you can pull them out of the frame, which in the end probably is not as neat a method, but cheaper, because there's less manual effort involved. And then we go to the next question. As a circular startup, how long did it take to reach break even, albeit as opposed to a conventional non-circular startup? That's a good question. I think quite some of the mistakes, maybe big word, of the bypasses that we made as a circular startup are due. And I think this is a danger for lots of impact startups, startups that not only commercialize a product or a service, but go towards an impact as well, being that social or environmental or any other, is that you tend to take that challenge too seriously and try to do it too good in the beginning. Like, for example, the lenses that go into the sunglasses, it took me a lot of time to actually not care too much about it. But before doing that, you spend a lot of time and energy trying to find lenses that are actually recyclable. And that's an investment that you do that you cannot really afford as a startup, but as we are committed to really making them as circular as possible, that's a cost that you do. So I think reaching break even at a later point is often true for circular startups, but in a more general sense, true for impact-driven projects and startups. Then we've got a question from Yannick. To what extent can the products be imperfect as a consequence of the 3D printing process or recycled content? My colleague Francesca Uzduzzi often refers to the swabby-wabby philosophy in her courses. Yeah, absolutely. That is one other thing that I confess a lot of mistakes that I made in the beginning, is that I really wanted to make sunglasses with FDM 3D printing that were as smooth, as perfect as possible. So you tend to first tumble them, then polish them, maybe too much, because indeed what you referred to, Yannick, is very true. Having the characteristic feel and layer that you get out of a 3D printed product has its own beauty in itself, which is nice to a certain level, but only if, but that's a personal thing, if you can control it as a whole over a whole production process, because it's a thin line I always find between doing something which feels sustainable, feels authentic, and you can still see and feel, maybe smell, that there's still recycled materials without making it too tree huggerish or eco feel. It needs to be recognizable, I think, that it is from recycled materials without having it scream it. But before that, it's more difficult to make it to make the imperfections reliant. Does that answer your question? So the imperfections are controllable to a certain point, which didn't really work. Anyone else a question by chat or?
Okay, I would say nobody has any questions anymore.
Well, if you would have questions in the future, feel free to reach out either via LinkedIn or via my email, which you certainly can get via Yannick. Always happy
Yes.
to share our findings.
Okay, if nobody has, if all questions are asked, there's all that's left is to thank Sebastian for having this very inspiring talk. I think we can conclude that the road to bringing a circular product to the market is not an easy one, but it's well worth it. And I think we all have to do our share in helping drive these changes, and sunglasses are definitely, in our opinion, a great way of bringing these, this way of designing, this way of looking to products close to the consumer. It's easier to grasp maybe than a technical part out of your vacuum cleaner, which is made out of recycled plastics. So the technology is under the hood, was under the hood, but now it's brought into close contact with the user, which is good. But maybe on the last moment, there's still one more question for Maarten, from Maarten. So no problem, Maarten. If that's okay, Sebastian,
Yeah, sure.
we will then conclude with the
No,
question.
that's perfectly fine. Perfectly
from
fine.
Yep.
That's good. I cannot answer the question. I know there is such a platform. I know it exists. I've looked at those several times, but they haven't found the quite materials that we were looking for. I don't remember the name, but if there's one place that you could ask where they surely will know, is with Vlaanderen Circulair. That's the Flemish organization on circular economy. They will certainly have the name of this platform. It's exactly what you say. It's like a trading platform where companies put forward the kind of waste streams that they have, the lead time, the volumes, eventually costs. It becomes like a trading place. It exists.
I think probably also a good place to go in terms of recycled, especially plastics. Then is to attend the K-messe in Düsseldorf. I think that's every 2 or 3 years it takes place. But I recall when we paid a visit with the students during the last edition, there was like a very big focus on circular economy and on recycled contents. Of course, yeah, there you have the big players, but it's very interesting to see, and I think to get in contact with some people. So the K-messe is definitely also a resource to keep in mind. It's a lot of plastic combined. It's a huge expo venue, but it's quite interesting to see what is possible already, and things shift fast, I have to say. Okay, then if there are no more questions, we will conclude here. Thank you again, Sebastian. Thank you again, Thomas, for co-hosting this webinar. Of course, we hope that everybody stays in touch with us throughout this year, either to participate in Circular Sprint 2021. Know that we do plan on hosting a few more webinars leading up to the 2021 event, and similar to this one, they will be inspiring events in linking additive manufacturing to circular design or vice versa. So all there's left to me is to wish you a happy, good afternoon, good continuation of your day, and let's stay in touch.